Whenever a class hides its methods and variables, this is called encapsulation, data hiding. But encapsulation is also used to define when one class has all its state and all of its behavior. Let's have a look at an example here. Remember, we have one class which is state and behavior. Now, this is the state, variables, this is the behavior. In this case, this class is an example of encapsulation because everything that you need to know about, in this case about an ATM, is contained within that class. Everything it does and everything it knows. If I want to understand what an ATM does, I need to look at that class and nowhere else. That is encapsulation, the first meaning of it. Second meaning is that I can also hide those to the outside world. So for example, here I've made these variables private. And even though these are all public methods, I could also make some methods private or protected. And that means that, for example, if I use gets and sets, which we'll see later on are called accessors and mutators, I can control access to these variables. For example, if I have the balance of a bank account, I may not want people, I definitely won't want people to be able to access that from the outside and increase their balance and give more money to themselves. I'll definitely want them to use one of my methods to deposit money into the account, and that method will, audit things and do things properly. Let's look at that scenario in a bit more detail. Scenario number 1 up here. Banks are very trusting places. Everybody just walks in and puts their gold bars and their money in a safety room, which is wide open, and they keep a record themselves of how much money they have in there. So next time they go, they can take it out either in bit by bit or in lump sum. Okay, may or may not work, bit of a utopian situation. But look at number 2. Number 2 is a bit closer to what we have in real life. You walk in and you either make a deposit with someone that sits in the deposits desk, or you make a withdrawal. And when you do make a withdrawal, either way they keep records of what you've done, and when you make a withdrawal they check that you actually have enough money in there, greater or equal to the amount that you want to withdraw. Now, all of that functionality I've just talked about is possible if I make people use a method, deposit and withdraw, to access the balance variable. But in this situation up here, I've just allowed people to access the public balance variable, and therefore I can't really enforce any rules about or keep any records of what's happened, because people can just go straight in and touch the variable themselves and change it to anything they want to, which is the equivalent of just walking into a safe in a bank and taking anything you want to. So encapsulation, a class holds its own state and behavior. That's the first meaning. And this, by the way, helps teams incredibly work on a system, because they don't need to understand each other's code, and the changes that they make to their own areas have a minimal or zero effect on each other. For example, if I'm working on the ATM class, and that's my job, then that's not going to affect the customer class and the team that are working on the customer ones as well. Encapsulation can also mean that we hide variables, and we can use gets and sets, or accessors and mutators as they're called. If I want to control access to a variable, then I don't have to provide a get and a set. That's optional. I might, for example, provide a get without a set, which means that effectively that variable would be read-only.